In this video, we'll be discussing slope of a chord, equation of a chord, and length of a chord in case of an ellipse. So suppose we have an ellipse whose equation is x square upon a square plus y square upon b square equals to 1. So we'll draw this ellipse. Now say we have a chord which joins 2 points on this ellipse, P and Q, and suppose coordinates of P are A cos alpha, B sin alpha, and suppose Q is A cos beta and B sin beta. Now the first thing that we'll find is slope of this chord. So slope of this chord is given by B, and then we can write sin beta minus sin alpha upon A cos beta minus cos alpha. Now we'll use the formula for sin C minus sin D. So it will be 2 sin beta minus alpha by 2 into cos beta plus alpha by 2. And here it will be A and then minus 2 sin alpha plus beta upon 2 into sin beta minus alpha upon 2. Now we can cancel this 2 and we can also cancel this sin beta minus alpha upon 2. So slope of this chord will be minus b upon a cot beta plus alpha upon 2. Now we'll come to equation of this chord. So once we have slope and we have point, then we can write equation of this chord. So once we have slope and we have point, then we can write equation of chord as y minus y1. So it will be y minus b sin alpha, and then slope which is minus b upon a, and we'll write this chord as cos alpha plus beta upon 2 upon sin alpha plus beta upon 2, and then x minus x dash, which is a cos alpha. Now we'll cross multiply. So we'll cross multiply, then we can write this as ay sin alpha plus beta upon 2 minus ab sin alpha into sin alpha plus beta upon 2, and here it will be minus bx cos alpha plus beta upon 2, and then plus ab cos alpha plus beta upon 2 into cos alpha. Now we'll take this x on the left hand side and we'll take this ab sin alpha plus beta by 2 on the right hand side. Then we can simply write this as bx cos alpha plus beta upon 2 plus ay sin alpha plus beta upon 2, and here it will be ab. Now this is cos a cos b plus sin a sin b. So cos a cos b plus sin a sin b is basically cos a minus b. So now it will be cos and then alpha minus alpha plus beta by 2. So it will be simply cos alpha minus beta by 2. Now what we'll also do is we'll divide it with ab. So we'll divide this equation with ab, x upon a cos alpha plus beta upon 2 plus y upon b sin alpha plus beta upon 2, and this is equal to cos alpha minus beta upon 2, and that is the equation of any general chord of an ellipse. Now the third thing that we'll work out is length of the chord. So length of the chord simply will be under root of x2 minus x1. So it will be a cos alpha minus cos beta whole square, and then plus b sin alpha minus sin beta whole square. So now we can write this as under root of, so this is a square and here it will be 4 sine square alpha minus beta by 2 into sine square alpha plus beta by 2 plus b square, and here it will be 4 sine square alpha minus beta upon 2 into cos square alpha plus beta upon 2. Now from this we can take 4 sine square alpha minus beta by 2 common. So we'll take it common, then we can write 2 mod sine alpha minus beta upon 2, and then it'll be this under root sine a square sine square alpha plus beta upon 2 plus b square cos square alpha plus beta upon 2, and that is the formula for length of a general chord of an ellipse. Now we'll come to focal chord of an ellipse. So suppose we have an ellipse. Then any chord which passes through focus is called as focal chord. So say we have this chord which is PQ, and this P is A cos alpha, B sin alpha, and suppose Q is A cos beta, B sin beta, and it passes through one of the focus which is say AE, 0. Now we need to find condition that this PQ is a focal chord. So we know that equation of a chord which passes through P and Q is given by x upon A cos alpha plus beta upon 2 plus y upon B sin alpha plus beta upon 2, and it is equal to cos alpha minus beta upon 2. Now if this chord is a focal chord, then it must pass through focus of this ellipse. Suppose this equation, it passes through AE, 0, then we'll put x as AE and y as 0. Then we can simply write E cos alpha plus beta upon 2 is equal to cos alpha minus beta upon 2. Now we can write this as E cos A plus B is cos A cos B minus sin A sin B. So then we can write cos alpha by 2 into cos beta by 2 and minus sin alpha by 2 into sin beta by 2, and it'll be equal to cos A cos B plus sin A sin B. So it'll be cos alpha by 2 into cos beta by 2 and then plus sin alpha by 2 into sin beta by 2. Now we'll take terms of cos alpha by 2 cos beta by 2 together, and then sin alpha by 2 and sin beta by 2 together. Then we can write E minus 1 cos alpha by 2 into cos beta by 2, and it is equal to E plus 1 sin alpha by 2 into sin beta by 2. So from here we can say tan alpha by 2 into tan beta by 2, it must be equal to E minus 1 upon E plus 1. So this is one of the result which is generally asked in focal chord of an ellipse. Now if the chord passes through other focus which is say S2, which is say minus AE, 0, in that case we'll write minus E cos alpha plus beta upon 2, and it'll be equal to cos alpha minus beta upon 2. So here we can write minus E and then cos alpha by 2 cos beta by 2 minus sin alpha by 2 sin beta by 2, and here it will be cos alpha by 2 cos beta by 2 and plus sin alpha by 2 into sin beta by 2. So we'll simplify, then we can write 1 plus E cos alpha by 2 into cos beta by 2, and it'll be equal to E minus 1 sin alpha by 2 into sin beta by 2. So from here we'll have this result, which is 10 alpha by 2 into 10 beta by 2, and it should be equal to e plus 1 upon e minus 1. Now another result about focal chord, which we have already proved in parabola, and we have actually proved it using polar form for any general conic including ellipse, and that is, if we have a focal chord whose segments are say L1 and L2, then harmonic mean of these focal segments is equal to semi-latus rectum. So we have this third result, which is harmonic mean of L1, L2 must be equal to semi-latus rectum. I'll put the link to that video in the description below. 2 L1, L2 upon L1 plus L2, it must be equal to semi-latus rectum, which in the case of ellipse will be b square upon a. So that is the third result that we generally use in case of a focal chord. In this video, we'll discuss condition of tangency and length of the chord. So suppose we have any ellipse which is, say, x square upon a square plus y square upon b square equals to 1, and then we have a line which is y equals mx plus c. So first we'll find point of intersection of this line with ellipse. So what we'll do is we'll eliminate y. We can write this equation as x square upon a square plus mx plus c whole square upon b square, and it is equal to 1. So this equation will now become b square x square plus a square m square x square plus c square plus twice mcx, and this is equal to a square b square. Now we can write this equation as a quadratic equation in x. So we'll write it as b square plus a square m square x square plus 2a square m into c into x plus a square into c square minus b square equals to 0. Now we know that condition of tangency is this line and ellipse must have only one point of intersection, and the condition that this line is a tangent to this ellipse is simply d equals to 0. So we'll simply find d and we'll put it equal to 0. So now it becomes 4 a to the power 4 m square c square minus 4 b square plus a square m square a square c square minus b square equals to 0. Now here we'll take 4a square common. So then we can write a square m square c square minus, and here it will be b square c square minus b to the power 4 plus a square m square c square minus b square a square m square equals to 0. Now here we can cancel a square m square c square. So now we can write b square c square, and it is equal to b to the power 4 plus b square m square a square. Now we'll also cancel this b square, then we can write c square, and it is equal to a square m square plus b square. So the condition of tangency in the case of ellipse is if the line y equals mx plus c is a tangent to this ellipse, which is x square upon a square plus y square upon b square equals to 1, then c square must be equal to a square m square plus b square. Now once we have this value of c, we can also write equation of tangent in terms of slope. So one of the equation of tangent for an ellipse which is x square upon a square plus y square upon b square equals to 1 is y equals mx. Now in place of c, we'll write under root of a square m square plus b square. So it will be y equals mx plus minus under root of a square m square plus b square, and that is the first equation of tangent in case of an ellipse. So if we are given a slope, then we can write equation of tangent to the ellipse as y equals mx plus minus under root a square m square plus b square. So condition of tangency is c square must be equal to a square m square plus b square, and equation of tangent is y equals mx plus minus under root a square m square plus b square. Now we'll come to the second part, which is length of the chord. Now suppose this point is x1, y1 and this point is x2, y2. Now we can write distance between PQ as under root of x2 minus x1 whole square plus y2 minus y1 whole square. Now we know that these P and Q, they lie on this line, which is y equals mx plus c. So we can write y2 equals mx2 plus c and y1 equals mx1 plus c. So from here we can write y2 minus y1 is m x2 minus x1. So we'll put the value of y2 minus y1. Then we can write PQ as under root of x2 minus x1 whole square plus m square into x2 minus x1 whole square. We can write under root of 1 plus m square into mod of x2 minus x1. Now we know that this equation will now have two distinct roots when d is greater than 0. Now the roots will be x1 and x2. Now if we write sum of roots, it will be x1 plus x2 is minus b upon a. So it will be simply 2 a square m into c upon b square plus a square m square, and then we can write product of roots, which is x1 x2, and there will be a square c square minus b square upon b square plus a square m square. So we can write x2 minus x1 as under root of 1 plus m square, and here we'll write it as under root of x1 plus x2 whole square minus 4 x1 x2. So we'll put the value of x1 plus x2 and x1 into x2. Then we can simply write PQ as under root of 1 plus m square into under root of, now what's x1 plus x2? It is 2a square m into c. So there will be 4 a to the power 4 m square c square upon b square plus a square m square whole square minus 4, and what's x1 x2? It will be 4 a square c square minus b square upon b square plus a square m square. Now from this we can take 4a square common, and we can also take b square plus a square m square common. So we can write this PQ as 2a upon b square plus a square m square into under root of 1 plus m square, and then we'll have a square m square c square minus c square minus b square into b square plus a square m square. Now we'll further simplify it. We can write this as 2a upon b square plus a square m square into under root of 1 plus m square. Now here in this case, a square m square c square and a square m square c square will cancel. So we'll get b to the power 4 plus b square a square m square and minus b square c square. Now we can also take b square common. So we'll write 2ab upon b square plus a square m square into under root of 1 plus m square, and then under root of a square m square plus b square minus c square. So that is the length of this chord PQ. Now this formula in itself is not important, and you're not supposed to memorize this formula. What's important in this expression is how to correlate this quadratic equation with distance formula. That is the only takeaway from this problem. Now we'll discuss equation of a director circle. Now we have already studied in case of parabola, director circle is locus of point of intersection of perpendicular tangents. So if we have any ellipse whose equation is x square upon a square plus y square upon b square equals to 1, and we'll draw this ellipse also. Then we need to find locus of point of intersection of perpendicular tangents. Now suppose this locus is some point P whose coordinates are alpha comma beta. Now we know that for this ellipse, equation of tangent is given by y equals mx plus minus under root of a square m square plus b square. Now this tangent will pass through this point which is alpha comma beta. So we'll put the value of x and y. So we can write beta equals m alpha plus minus under root of a square m square plus b square. Now we'll take this m alpha on the left hand side and we'll square. Then we can write beta minus m alpha whole square, and it will be a square m square plus b square. So we'll get beta square m square alpha square minus 2 m alpha beta, and it will be a square m square plus b square. So we can actually write this equation as a quadratic equation in m. So we'll write it as a square minus alpha square m square plus 2m alpha beta, and then plus b square minus beta square equals to 0. Now this equation will have two real roots. So we'll have two roots, say m1 and m2. Now it is given that these tangents, they are perpendicular. If the tangents are perpendicular, then clearly m1 into m2 is equal to minus 1, and m1 into m2 is nothing but product of root, and product of root is c upon a. So from here we can write b square minus beta square upon a square minus alpha square, and this is equal to minus 1. So we'll rearrange it. We can write it as alpha square plus beta square, and it should be equal to a square plus b square. Now we'll replace alpha with x and beta with y. So equation of director circle will be x square plus y square, and it'll be equal to a square plus b square. So locus of point of intersection of perpendicular tangents is this circle whose center is same as the center of ellipse and whose radius is under root of a square plus b square. So we'll have this circle, and from any point on this circle, pair of perpendicular tangents can be drawn. We'll be using the concept of director circle when we have questions where, say for example, an ellipse such that it touches both x-axis and y-axis, or in the questions where an ellipse is inscribed inside a square. There we'll use condition of director circle, and which is center of this circle will be same as center of this ellipse and its radius will be under root of a square plus b square. Now if we have any ellipse whose center is not at origin, say for example, suppose equation of ellipse is x minus h square upon a square plus y minus k square upon b square equals to 1. And in this case, equation of director circle will be x minus h square plus y minus k square, and it must be equal to a square plus b square. In this video, we'll work out position of a point with respect to ellipse. We'll find equation of tangent if the point lies on ellipse. If the point lies outside the ellipse, then we'll also find equation of chord of contact. From an external point, two tangents can be drawn. Then we'll also work out equation of pair of tangents. And finally, equation of a chord whose midpoint is given. So suppose we have an ellipse whose equation is given by s equals to 0, and which in this case is x square upon a square plus y square upon b square minus 1 equals to 0. And we have a point P which is say x1, y1. Now we can find S1. So all we need to do is we'll just need to put the value of x and y in the equation. So we'll replace x with x1 and we'll replace y with y1. So we'll get x1 square upon a square plus y1 square upon b square and minus 1. Now this S1, it's a value which could be negative, positive or 0. So if the value of S1 is 0, it simply means point lies on ellipse. If S1 is greater than 0, then point lies outside the ellipse, and if S1 is less than 0, then point lies inside the ellipse. So in the first case, we have this ellipse, and now this point P, it lies on the ellipse. So in which case, value of S1 is simply 0. Now if the point lies on the curve, then the best way to find equation of tangent is T equals to 0. So if the point lies on ellipse, then equation of tangent is given by T equals 0. Now how do we write T? Now in place of x square, we'll write x x1, and in place of y square, we'll write y y1. So equation of tangent is given by x x1 upon a square plus y y1 upon b square, and it is equal to 1. So this is the equation of tangent drawn at a point P whose coordinates are x1 and y1. Now there will be some questions in ellipse where we need to find this point P. So what we will do is we write equation of tangent, which is x x1 upon a square plus y y1 upon b square equals to 1. And we know that this point P, it will also lie on this ellipse. So we'll have another equation which will be x1 square upon a square plus y1 square upon b square equals to 1. Now we can solve these two equations to find the value of x1 and y1. So this is how we can find point of contact of any given tangent. We can also write this equation in another form, and we can write it in terms of parametric coordinate. We know that any point on ellipse, we can express it as a cos theta and b sin theta. Now if we write equation of tangent at this point P, then it is given by T equals to 0. We write x x1, and x1 is a cos theta upon a square plus y, and y1 is b sin theta upon b square equals to 1. So equation of tangent in terms of parametric coordinates is given by x cos theta upon a plus y sin theta upon b, and this is equal to 1. And this again is very important equation for solving problems. So while solving problems, either we'll use y equals mx plus minus under root a square m square plus b square, or we'll use this, which is x cos theta upon a plus y sin theta upon b equals to 1. And in case we need to find this point of contact, then we'll use x x1 upon a square plus y y1 upon b square equals to 1. Now we'll come to the second case when point lies outside the ellipse. So if point lies outside this ellipse, now if the point lies outside the ellipse, then clearly S1, it should be positive. And in that case, we can draw two tangents from this given point. Now these 2 points A and B, they are point of contact. Now any line joining these point of contact is called as chord of contact. So this line AB is actually chord of contact. Now if the point P lies outside the ellipse, then in that case, equation of chord of contact is given by t equals to 0. So if point lies outside, then this equation, which is x1 upon a square plus y1 upon b square equals to 1, will not represent a tangent, but it will represent equation of chord of contact. When the point P lies outside, in that case, a pair of tangents can be drawn. Equation of pair of tangents is given by SS₁ is equal to T square, which is same as in the case of a parabola. So we know that this S is equation of ellipse. S1 is the value, once we put the value of x1 and y1, and this t equals to 0 is equation of this line, which is x1 upon a square plus y1 upon b square minus 1. If the point lies inside the ellipse, then in that case simply S1 is less than 0, and then we cannot draw any tangent through this point P. So we have discussed position of a point, equation of tangent, equation of chord of contact, and equation of pair of tangents. Now we'll come to equation of chord whose midpoint is P. So if in an ellipse we have a chord whose midpoint is say P, which is x1 y1, then we can write equation of chord whose midpoint is P, which is x1 comma y1, and this equation is given by t equals S1. So this is how we can write equation of any chord whose midpoint is given. In this video, we'll be discussing diameter of an ellipse. So suppose we have an ellipse whose equation is x square upon a square plus y square upon b square equals to 1. Let us draw this ellipse. Now we need to find diameter of this ellipse. Now by definition, diameter is locus of midpoint of parallel chords of an ellipse. So say for example, suppose we have a system of parallel chords and if we'll join midpoints of all these chords, then this locus will be a straight line, which is called as diameter of this ellipse. So we have system of parallel chords whose slope is m. So all these lines, they'll be of the form y equals mx plus c, where m is fixed and c varies. Now we need to find equation of its diameter. Now since it is a locus problem, what we'll do is we'll say let the midpoint be alpha beta. Now we know that equation of a chord whose midpoint is P is given by t equals S1. So we'll write equation of this chord. So equation of this chord will be alpha x upon a square plus beta y upon b square minus 1, and it will be equal to alpha square upon a square plus beta square upon b square minus 1, which will cancel. So we'll get this equation as alpha x upon a square plus beta y upon b square, and will be equal to alpha square upon a square plus beta square upon b square. So this is the equation of a chord whose midpoint is alpha beta. Now we know that slope of this chord is m. M equals slope of this line minus coefficient of x, which is alpha upon a square, upon coefficient of y, which is beta upon b square. So from here we'll get this condition, which is minus b square alpha upon a square beta. Now we'll replace alpha with x and beta with y. So equation of this diameter will be y equals minus b square upon a square m into x. So that is the equation of diameter of system of parallel chords whose slope is m. So this chord, it is a straight line which passes through center of this ellipse. Now with diameters, we also study something which is also called as conjugate diameters. two diameters are said to be conjugate when each bisects all chords parallel to the other. Say for example, suppose we have two diameters which are y equals mx and y equals m dash x. Now we know that for this line, equation of diameter will be given by y equals minus b square upon a square m into x. Now if this line is the diameter for this given system of chord, then in that case simply m dash must be equal to minus b square upon a square m. So the condition that we'll get from here is m dash must be equal to minus b square upon a square m, or we can also write it as m into m dash is minus b square upon a square. So if the product of two slopes is equal to minus b square upon a square, in that case the two diameters are said to be conjugate diameters of each other. Now there are some results on conjugate diameter, and the first result is the tangent at the extremity of any diameter is parallel to the chord which it bisects. So suppose we have an ellipse, again whose equation is x square upon a square plus y square upon b square equals to 1. Now suppose we have a chord whose equation is y equals mx plus c, and then we have its diameter whose equation will be y equals minus b square upon a square m x. Now we need to prove that tangent at the extremity of any diameter is parallel to the chord which it bisects. Now what we'll do is we'll say let there be a point P which is say x dash y dash which lies on this ellipse such that tangent at this point is parallel to this given chord. So we know that equation of tangent at any given point is x dash upon a square plus y dash upon b square equals to 1. Now since this tangent is parallel to this chord, then we can simply write m equals minus, now coefficient of x is x dash upon a square upon y dash upon b square. So from here we can write y dash equals minus b square x dash upon m a square. So we get this result which is y dash equals minus b square upon a square m into x dash, which simply means this x dash y dash will lie on diameter of this chord. This point P, it lies on this diameter, and the tangent drawn at this point P will be parallel to the chord which this diameter bisects. Now another result is the tangents at the end of any chord meet on diameter which bisects the chord. So if we have this chord, say AB, and if we draw tangents at A and B, we need to prove that their point of intersection will lie on diameter of this chord. So what we'll do is we'll assume that let this point of intersection be P, which is alpha comma beta. Now we can write equation of this line AB. Equation of this line AB is given by t equals to 0. If the point lies outside, then equation of chord of contact is given by t equals 0. So we can write this equation as alpha x upon a square plus beta y upon b square equals to 1. Now it is given that slope of this line is m. So if we'll find its slope, we can write m equals minus alpha upon a square beta upon b square. So from here again we can write beta equals minus b square upon m a square into alpha, which simply means this alpha beta will again lie on diameter of this chord. Now the third result is if the eccentric angle of the ends P and D of a pair of conjugate diameters be theta and alpha, then we need to prove that theta and alpha differ by a right angle. So we'll take up an ellipse. Suppose the equation is x square upon a square plus y square upon b square equals to 1. Now we have two conjugate diameters. This is our center. Now suppose this point is P and this point is D. Now let this point P be A cos theta, B sin theta, and let this point D be A cos alpha and B sin alpha. Now center of this ellipse is at origin. So we can write equation of this line. So equation of this line CP, it will be y equals B sin theta upon A cos theta x, and the same way we can write equation of CD, which will be y equals B sin alpha minus A cos alpha into x. If they are conjugate diameters, then the condition is m into m dash must be equal to minus b square upon a square. So if we'll multiply these two slopes, we'll get b square upon a square sin theta sin alpha upon cos theta cos alpha, and this is equal to minus b square upon a square. So we can cancel b square and a square. So from here we'll get this condition, which is cos a cos b plus sin a sin b, and there'll be cos a minus b. So it should be cos theta minus alpha equals to 0. Now cos is 0 when theta is an odd multiple of pi by 2. So that means theta minus alpha is 2n plus 1 into pi by 2. So that means these two eccentric angles, they differ by either pi by 2 or minus pi by 2. Now another result is if PCP dash and DCD dash be a pair of conjugate diameters, then we need to prove that first CP square plus CD square is constant, and we need to prove that the area of parallelogram formed by tangents at the end of these diameters. So if we'll draw tangents at the end of these diameters, we need to prove that area of this parallelogram is also constant. Say this parallelogram is K, L, M and N. So we need to prove that area of K, L, M, N is constant. Now we have already established that these two eccentric angles, they differ by an angle pi by 2. So what we'll do is we'll say this P is A cos theta, B sin theta, and this D will be A, and then we can write alpha as cos pi by 2 plus theta and B sin pi by 2 plus theta. So we can write this D as minus A sin theta and B cos theta. CP square will be A square cos square theta plus B square sin square theta. Now in the same way we can write CD square. CD square will be A square sin square theta plus B square cos square theta. Now we'll add them, then we can write CP square plus CD square, and it will be equal to A square plus B square, which is independent of theta. So that means CP square plus CD square is constant. Now we'll come to this second result. We need to find area of this parallelogram. So from symmetry we can say that area of KL MN, it will be 4 times area of this parallelogram CDKP. So KDCNP. Now what we'll do is from this C we'll drop a perpendicular on this side PK, then we can write this area as 4 times this value, which is say CR into PK. Now this PK is equal to CD, so we can write this is 4 times CR into CD. Now we need to find this perpendicular distance of tangent at P from center C. So we know that equation of tangent at this point P will be given by x cos theta upon A plus y sin theta upon B minus 1 equals to 0. And if we drop a perpendicular from origin, we can find this distance, which is CR, and this distance will be 0 plus 0 minus 1 upon under root of cos square theta upon A square plus sin square theta upon B square. The CR will be AB upon under root of B square cos square theta plus A square sin square theta. Now A square sin square theta plus B square cos square theta is nothing but CD square. So from here we can say this CR, it will be equal to AB upon CD, that is CR into CD is equal to AB. Now we need to find this area. So area of this parallelogram KLMN is equal to 4 times CR into CD. So that will simply be 4AB. So that means area of the parallelogram is again constant and its value is equal to 4AB. In diameters, we also have another condition which is called as equi-conjugate diameters. Two diameters are said to be equi-conjugate diameters if CP square is same as CD square. So if these two lengths they are same, then we'll say these two diameters are equi-conjugate diameters. Now we know that CP square is A square cos square theta plus B square sin square theta, and it must be equal to A square sin square theta plus B square cos square theta. So the result that we'll get from here is cos 2 theta must be equal to 0. So that means 2 theta must be equal to 2n plus 1 pi by 2, or theta must be equal to 2n plus 1 into pi by 4. So it simply means if two diameters are equi-conjugate diameters, then in that case value of theta must be either pi by 4 or 3 pi by 4. And if we'll put the value of theta as pi by 4, then we can find its length, which is CP and which is same as CD, and it will be equal to under root of, now cos square theta, it is 1 by 2, and sin square theta is also 1 by 2. So this length will be A square plus B square upon 2. So that is the condition of equi-conjugate diameters. Now the next question is, if the lines root 3y minus x equals to 3 and x equal to 2 are tangents to these ellipse, we need to find eccentricity and length of lattice rectum and area of this ellipse. So we know that the line x equals to 2 can be tangent to this ellipse only when the value of a is 2. So that means this ellipse, it passes through 2, 0. So we can say that value of a is simply 2. Now for this other tangent, we can write this equation as y equals 1 upon root 3x plus root 3. And in this case, value of m is 1 by root 3. Value of c is root 3. Now condition of tangency is c square equals a square m square plus b square. Now c square is 3, a square it is 4, and m square is 1 by 3. So it will be 4 by 3 plus b square. So from here we'll write b square as 9 minus 4. So it will be simply 5 by 3. So now we have a and we also have b. So we can write eccentricity of this ellipse. So eccentricity is b square equals a square into 1 minus e square. Now b square in this case is 5 by 3, a square is 4, and it will be 1 minus e square. So we can write this as e square equals 1 minus 5 by 12. So it will be 12 minus 5, 7. So it will be 7 by 12. So eccentricity of this ellipse will be under root of 7 by 12, which is under root 7 upon 2 root 3, and that's your option number A. We can also write area of this ellipse. So we know that area of ellipse is pi AB. So we have pi, and then what's the value of A? A is 2, and what is the value of B? B is under root of 5 by 3. So area of this ellipse is 2 pi under root 5 by 3, and that's your option D. And finally, we need to find length of lattice rectum. Length of lattice rectum is 2b square upon A. So it will be 2. And now what's b square? B square is 5 by 3. Value of A is again 2. So length of lattice rectum is 5 by 3, and that's your option number C. So for this question, Options A, C and D, they are correct. Now here the question is, if a tangent of slope minus 4 by 3, so value of m is minus 4 by 3 to the ellipse x square upon 18 plus y square upon 32 equals to 1 intersects the major axis and minor axis in A and B. If the area of triangle OAB is A units, then we need to find the value of A by 4. Now we know that equation of tangent is given by y equals mx plus minus under root of a square m square plus b square. Now this equation is valid for both, for the first form as well as for the second form. Now this ellipse, it is actually second form, but still we'll solve it taking this as equation, considering 18 as a square and 32 as b square. So now we can write y equals minus 4 upon 3x plus minus under root of a square. A square is 18 and then m square will be simply 16 by 9 and then plus b square which is 32. So we can write this equation as y equals minus 4 upon 3x plus minus, now here it will be 2, 32 plus 32, 8. So we can write this equation as 4x plus 3y is equal to plus or minus 24. We can also write this equation as x upon 6 plus y upon 8 equals plus or minus 1. Now we'll consider positive value of intercepts, then we can simply write OA is 6 and OB is 8. Now what is area of this triangle OAB? Area of this triangle OAB will simply be 1 by 2 into 6 into 8. So there will be 24. Now we need to find the value of A by 4. Now A by 4 is 24 divided by 4, which is 6. So answer to this question is 6 square unit. Now here the question is, if a tangent of slope 2 of the ellipse x square upon a square plus y square upon b square equals to 1 is normal to the circle x square plus y square plus 4x plus 1 equals to 0, then we need to find maximum value of AB. Now we already know that equation of tangent to any ellipse is given by y equals mx plus minus under root of a square m square plus b square. And the question m is already given and which is 2. So we can write this equation as y equals 2x plus minus under root of 4a square plus b square. Now this tangent to this ellipse is normal to this circle. So we know that any normal to a circle, it passes through center of the circle. Center of the circle is at minus 2, 0. So what we'll do is we'll put the value of x and y. So we'll put the value of x and y, then we'll get 0. And this is minus 4 and it will be equal to 4a square plus b square. So we'll square it. We'll get this condition as 4a square plus b square and 4a square plus b square, and it is equal to 16. Now in order to find maximum value of AB, we'll use condition of arithmetic mean and geometric mean. So we'll find arithmetic mean of these two numbers, 4a square and b square. So 4a square plus b square upon 2 will always be greater than or equal to under root of 4 a square b square. So we'll put the value of 4a square plus b square. We can write 8 is greater than or equal to 2ab, that is a into b is always less than or equal to 4, that is the maximum value of ab is simply 4. Now here the question is, we need to find angle between the pair of tangents drawn from the point 1, 2 to this ellipse, which is 3x square plus 2y square, and it is equal to 5. So we'll write this equation as x square upon 5 by 3 plus y square upon 5 by 2, and it is equal to 1. Now we can write equation of tangent to ellipse as y equals mx plus minus under root of a square, which is 5 by 3, m square plus 5 by 2. Now we need those tangents which pass through this point, which is 1, 2. So we'll put the value of x as 1 and y as 2. So it'll be 2 minus m, and it'll be equal to plus minus under root of 5 and then 2m square plus 3 upon 6. Now we'll square both sides. So we'll square both sides. We'll get 6 and then 4 plus m square minus 4m, and it'll be equal to 10m square plus 15. So we can write this as 4m square plus 24m. Now 24 and then 15. So it'll be simply minus 9 equals to 0. Now this quadratic equation will have two real roots. So we can write sum of roots, which is m1 plus m2. So m1 plus m2 in this case will be minus b upon a. There will be 24 upon 4, and that should be 6. So m1 plus m2 is minus 6, and product of roots, which is m1 into m2, it is simply minus 9 by 4. Now we need to find angle between these two tangents. Now we know that angle between two lines is given by tan theta, and it is m2 minus m1 upon 1 plus m1 m2. Now we can write m2 minus m1 as m1 plus m2 whole square minus 4 m1 m2, and square root of this whole expression upon 1 plus m1 m2. Now we'll put the value of m1 plus m2 and m1 into m2. So we'll write this expression as under root of, now m1 plus m2 whole square, so there'll be 36, and then minus 4 m1 m2, so there'll be plus 9 upon 1 plus m1 m2, so it'll be 1 minus 9 by 4. So we'll get this as tan theta, and it'll be equal to under root of 45 upon 5 by 4, and we take a mod sign. Theta will be tan inverse, and should be 12 under root 5 upon 5, and that's your option number 1. Now here the question is, an ellipse passes through the point 4, minus 1, and its axes are along the axis of coordinates. If x plus 4y minus 10 equals to 0 is a tangent to it, then we need to find its equation. So let the equation be x square upon a square plus y square upon b square equals to 1. And since this ellipse, it passes through 4, minus 1, we can write 16 upon a square plus 1 upon b square, it is equal to 1. So we'll get this relation, which is 16b square plus a square, and it'll be equal to ab whole square, and that's our first result. Now we'll take up this equation. We can write this equation of tangent as y equals minus 1 by 4x plus 5 by 2. Now we know that condition of tangency is c square equals a square m square plus b square. Now c square in this case is 25 by 4. A square we need to find. Now m square will be 1 upon 16 plus b square. So from here we'll say a square plus 16b square, and this value will be equal to 100, and that's our second equation. Now we'll put the value of a square plus 16b square in the first equation. Then we'll get value of a into b square as simply 100. Now what we'll do is we'll put the value of a square in this second equation. Then it will become a quadratic equation b square. So we can write this equation as 100 upon b square plus 16b square, and it is equal to 100. So we'll write this equation as 16b to the power 4 minus 100b square plus 100 equals to 0, and we'll also divide it with 4. So we'll divide by 4, we'll get 4b to the power 4 minus 25b square plus 25 equals to 0. So from here we'll get the value of b square as either 5 by 4 or the value of b square is 5. Now if we'll put b square as 5 by 4, we'll get a square as 400 by 5. So there'll be 80. And if we'll put b square as 5, we'll get a square as 100 by 5, and that should be 20. So we'll have two equations of ellipse. So one of the equation will be x square upon 80 plus y square upon 5 by 4 equals to 1. And the other equation will be x square upon 20 plus y square upon 5 equals to 1. So one of the option is x square upon 80, 5 by 4. That's your option number B. And then we'll have 20 and 5, but here we have 4. So that means option B is the only option correct. Now in this question, we need to find the points at which tangents drawn are parallel to this line, which is 8x equals 9y. So let this point be x1, y1. Now this point, a lie on ellipse. So we'll have our first equation, and there'll be 4x1 square plus 9y1 square, and it is equal to 1. So that's our first equation. Now at this point, we know that equation of tangent is given by t equals 0. So we'll find t equals 0. Its equation will be 4x(x1) plus 9y(y1), and it is equal to 1. Now what is the slope of this line? Slope of this line is minus coefficient of x upon coefficient of y. So there will be minus 4x1 upon 9y1. Now it is given that tangents are parallel to this line, which is 8x equals 9y. So slope of this line is 8 by 9. Now here 9 will cancel. So we can write x1 as minus 2y1, and that's our second condition. Now what we'll do is we'll put the value of x1. So we'll put the value of x1. So we'll get this as 16y1 square plus 9y1 square. So value of y1 square will be 1 upon 25. So value of y1 is plus or minus 1 by 5. And since x is minus 2y1, x1 is minus plus 2 by 5. So these points of contact, they'll be 2 by 5 minus 1 by 5 or minus 2 by 5 and 1 by 5. So answer to this question is option number B and option number D. Now here the question is, tangents PA and PB are drawn to this ellipse x square upon 16 plus y square upon 9, and it is equal to 1. Now this point is 4, 0, minus 4, 0, 0, 3 and 0, minus 3. Now from a point 0, 5, so we have a point on minor axis, which is from 0, 5, we have drawn two tangents. So tangents PA and PB are drawn to this ellipse. So this is PA and this point is PB. We need to find area of this triangle PAB. Now what we'll do is, from this point P, if we draw a pair of tangents, then this is chord of contact. Chord of contact is given by t equals to 0. So for this point 0, 5, we'll find t equals to 0. So we'll write x(x1). So there'll be 0x upon 16 plus 5y upon 9 equals to 1. So from here we'll write value of y is 9 by 5. So this line is y equals 9 by 5. Now once we have the value of y, we can find the value of x also. So we'll find these points A and B. So we'll put y as 9 by 5. We can write x square upon 16 plus 9 upon 25 is equal to 1. So x square upon 16, and it will be 16 upon 25. So value of x is simply plus minus 16 upon 5. So point B is 16 upon 5, 9 by 5, and point A is minus 16 upon 5 and 9 by 5. Now we need to find area of this triangle. So area of this triangle is half. Now base, what is the length of the base? Length of the base is 32 by 5. And what is height? Height in this case is 5 minus 9 by 5, which is 25 minus 9, 16 by 5. which is 256 upon 25 square units, and that's your option number B. Now let this point of contact be x1, y1. Now we know that equation of tangent drawn at this point x1, y1 will be given by t equals to 0, and there will be x1 plus 3y y1 equals to 6. Now this alpha beta, it will lie on this tangent. So we'll get this equation as alpha x1 plus 3 beta y1, and it is equal to 6, and that's our first equation. We'll get the second equation from slopes. So what is the slope of this line ON? Slope of this line ON will be beta upon alpha. And what is the slope of this tangent? Slope of this tangent is minus coefficient of x upon coefficient of y. So it will be minus x1 upon 3y1, and this value is equal to minus 1. So we'll cancel minus with minus, then we can write beta x1 is equal to 3 alpha y1, and that's your second equation. Now from these two equations, we'll find the value of x1 and y1. So what we'll do is, we'll eliminate y1, we'll put the value of y1 here, so we'll get alpha x1 plus 3 beta, and then y1 will be beta x1 upon 3 alpha, and it is equal to 6. Now this 3 will cancel. We can take x1 common, then we can write alpha square plus beta square upon alpha x1, and this is equal to 6. That is, the value of x1 is 6 alpha upon alpha square plus beta square. Now once we have x1, we can find y1. So we'll put the value of x1. We'll get y1 as, now here 6 alpha and 3 alpha will cancel, we'll get 2. So it'll be 2 beta upon alpha square plus beta square. So now we have x1 and we also have y1. Now we need to find relationship between alpha and beta. So we know that this x1, y1 will satisfy equation of this ellipse because it lies on this ellipse. So if x1, y1, it lies on this ellipse, then x1 square plus 3y1 square, and it must be equal to 6. Now we'll put the value of x1 and y1. So we'll get 36 alpha square plus 12 beta square upon alpha square plus beta square whole square, and this value, it is equal to 6. So we can write this as 12 3 alpha square plus beta square, and this is 6 times alpha square plus beta square whole square. We can cancel 6 with 12. So this required locus will be 2 times 3x square plus y square, and it is equal to x square plus y square whole square. 2 times 3x square plus y square is 6x square plus 2y square, and then x square plus y square whole square, and that's your option number A. Now here the question is, a tangent is drawn to the ellipse x square upon 27 plus y square equals to 1 at a point 3 root 3 cos theta, sine theta, where theta lies in first quadrant. Then the sum of the intercepts of the tangent with the coordinate axis is least when the value of theta is which of the following. Now we know that equation of tangent in case of an ellipse is given by x cos theta upon a. So it will be x cos theta upon 3 root 3 plus y sin theta upon b, and it is equal to 1. Now we'll write its intercepts. OA will be 3 root 3 secant theta, and OB will be cosec theta. Now we need to minimize their sum. So let the sum be S, and this sum be 3 root 3 secant theta plus cosec theta. Now in order to minimize it, we'll differentiate. So ds upon d theta will be 3 root 3, it is secant theta tan theta and minus cosec theta into cot theta. So we can also write this as 3 root 3 sin cube theta minus cos cube theta upon sin square theta into cos square theta. Now we'll put it equals to 0. We'll find its critical point. So from here we'll get this condition, which is tan cube theta is equal to 1 upon 3 root 3. That is the value of tan theta, it must be 1 by root 3. Now the value of tan theta is 1 by root 3 when the value of theta is pi by 6. So for this problem, the critical point is pi by 6. Now we'll take theta as pi by 4. In that case, this value will be positive. So rightmost is positive and this is negative. So that means this function first decreases and then increases. So that means at pi by 6, it is a point of local minima. So the sum of the intercepts will be least when theta is pi by 6, and that's your option number 1. Now here the question is, we need to find the area of a quadrilateral formed by the tangents at the end points of lattice rectum to the ellipse x square upon 9 plus y square upon 5 equals to 1. So we have this ellipse. At the end points of lattice rectum, we draw tangents. We need to find area of this quadrilateral. Now from symmetry we can say that area of this quadrilateral will be 4 times area of one triangle. So what we'll do is we'll find area of this triangle in the first quadrant and then we'll multiply it with 4 to write the area of this quadrilateral. Now for that we need to find equation of this tangent. Now we know that endpoint of lattice rectum is given by AE comma b square upon a. So at this point we can write equation of tangent and it will be given by t equals to 0. So a in this case is 3, b is under root 5. Now b square is a square into 1 minus e square. So e in this case will be 2 by 3. So the coordinate of endpoint of lattice rectum will be 2 comma b square by a. So there will be 5 by 3. Now we'll use t equals to 0 to find equation of this tangent. So equation of this tangent will be 2x by 9 plus 5y upon 3 into 5 equals to 1. So here intercepts are 9 by 2 comma 0 and 0 comma 3. So what is the area of this triangle? Area of this small triangle will be 1 by 2 and then 3 into 9 by 2. So there will be 27 by 4. Now area of this quadrilateral will be 4 times area of this triangle, which is simply 27 square units, and that's your option number D. Now here the question is, the tangent at any point P on the ellipse meets the tangent at the vertices A and A dash of ellipse at L and M. Then we need to find the value of AL into A dash M. So we have any ellipse which is x square upon a square plus y square upon b square equals to 1. Then at any point we'll draw tangent. So let this point be a cos theta, b sin theta. Now we know that at this point P, equation of tangent will be given by x cos theta upon a plus y sin theta upon b, and it is equal to 1. Now the question says this tangent, it intersects tangent at vertices A and A dash at L and M. So this is L and this is M. So for this point of intersection, we know that its x coordinate will be simply A. Now we'll put x coordinate as A, we'll get y coordinate as B 1 minus cos theta upon sin theta. So it will be B 1 minus cos theta upon sin theta. Now for this M, its x coordinate will be simply minus a, so it will be 1 plus cos theta. So this coordinate will be b 1 plus cos theta upon sin theta. Now we'll need to find product of AL into A dash M. So what's AL? AL simply is b 1 minus cos theta upon sin theta. And what's A dash M? It'll be b 1 plus cos theta upon sin theta. Now we'll multiply them. So AL into A dash M will be b square. Now a plus b, a minus b. So it'll be 1 minus cos square theta. So that should be sin square theta upon sin square theta, which will cancel. So this value is equal to b square, and that's your option number 2. Now here the question is, the minimum area of triangle formed by the tangent to this ellipse and coordinate axis is. So we have this ellipse. Then at any point we'll draw tangent. So equation of tangent is given by x cos theta upon a plus y sin theta upon b, and it is equal to 1. Now we'll find its intercepts. So its x-axis intercept will be a upon cos theta comma 0, and y-axis intercept will be 0 comma b upon sin theta. Now we need to find area of this triangle. So area of this triangle will be given by 1 upon 2 AB sin theta into cos theta. So this area, it will be AB upon sin 2 theta. Now this area, it's a function of this angle theta. Now this area, it will be minimum when the value of sin 2 theta is maximum. So maximum value of any sine is simply 1. So minimum value of this triangle is AB, and we'll get this minimum value when the value of sin 2 theta is 1. That is when 2 theta is pi by 2. That is when the value of theta is simply pi by 4. Minimum area is AB, and that's your option number A. Now here the question is, if the locus of the middle point of the portion of tangent to the ellipse included between the axes is a square upon x square plus b square upon y square equals to k, we need to find the value of k. So we know that equation of any tangent is given by x cos theta upon a plus y sin theta upon b equals to 1. So we'll find its intercepts. Its intercept will be a upon cos theta comma 0 and 0 comma b upon sin theta. Now we need to find locus of middle point of this intercept. Now let this midpoint be m, say alpha and beta. So alpha is x1 plus x2 upon 2, so it will be a upon 2 cos theta, and in the same way we can write beta, and there will be b upon 2 sin theta. Now we need to eliminate theta. So cos square theta plus sin square theta is 1. We write a square upon 4 alpha square plus b square upon 4 beta square equals to 1. So we'll write this locus as a square upon x square plus b square upon y square, and it is equal to 4. So that is the value of k is simply 4. Now here the question is, tangent at any point P of the ellipse 9x square plus 16y square equal to 144. That is, equation of this ellipse will be x square upon 16 plus y square upon 9, and it is equal to 1. So tangent at any point P is drawn. Now eccentric angle of P is theta, which is given by this relationship, which is equivalent to sin 2 theta, and this value is 1 by 7. Now it says, if n is the foot of perpendicular from center O to this tangent, so from the center, which is origin, what we do is we drop a perpendicular, then we need to find this angle, which is angle PON. Now we know that this point is a cos theta and b sin theta, so it will be 4 cos theta and 3 sin theta. Now slope of OP is, say, m1. So what is slope of OP? Slope of OP is 3 sin theta upon 4 cos theta, that is 3 by 4 tan theta. Now we need to find slope of ON. Now we know that equation of tangent is given by x cos theta upon A plus y sin theta upon B, and it is equal to 1. So what is slope of this tangent? So slope of this tangent will be minus 3 cos theta upon 4 sin theta. Now this line, it is perpendicular to this tangent. So M2 in that case will be 4 upon 3 tan theta. So now we have M1 and we also have M2. So now we can find angle between PON. So this angle, which is say alpha, we can write this as tan alpha, and it will be M2 minus M1. So it will be 4 by 3 tan theta minus 3 by 4 tan theta upon 1 plus M1 M2. Now this 3 by 4 and 4 by 3 will cancel, so will be 1 plus tan square theta. So we can simply write this as 7 by 12 tan theta upon 1 plus tan square theta. Now what we'll also do is we'll multiply it with 2 and divide it with 2. So we can write this as 7 by 24, and this 2 tan theta upon 1 plus tan square theta is nothing but sine 2 theta. Now in the question it says sine 2 theta is 1 by 7. So this value is 1 by 24. So this angle PON will actually be tan inverse 1 by 24, and which is your option number B. Now here the question is, if the tangent to the ellipse passes through the vertex of parabola, we need to find value of theta. So we can write this equation as x square upon 16 plus y square upon 4 equals to 1. So equation of tangent will be x cos theta upon A, which is 4, plus y sin theta upon B, which is 2, and it is equal to 1. Now it says this tangent, it passes through vertex of this parabola. So we can write this parabola as y square minus 4y minus 2x minus 4 equals to 0. So we'll add 4 and we'll subtract 4. We can write y minus 2 whole square, and it is equal to 2x plus 8. So this equation is y minus 2 square, and this is 2x plus 4. Now we'll compare it to the standard equation, which is capital Y square equals 4a capital X. So capital Y is y minus 2, capital X is x plus 4, and the value of a is 1 by 2. Now for this first form, its focus is at a comma 0. So capital X equals a, capital Y equals 0. So x is x plus 4, and this is equal to 1 by 2, and y is y minus 2 equals to 0. So value of x will be minus 7 by 2, and value of y is 2. So focus of this parabola is at minus 7 by 2 comma 2. So this tangent will pass through this focus. So we'll put the value of x and y. So it will be minus 7 cos theta upon 8 plus sin theta equals to 1. So we can write this equation as 8 sin theta minus 7 cos theta, and this value, it should be 8. Now we'll take theta as pi by 2. We know that sin 90 is 1 and cos 90 is 0. So theta equals pi by 2. It actually satisfies this equation. So answer to this question is the value of theta should be pi by 2. And that's your option number A. Now here the question is, the tangent at any point P on ellipse cuts the major axis in T, and Pn is the perpendicular to x-axis, and C being center, we need to find the value of Cn into Ct. So we have this ellipse whose center is at C. Then from any point P, we draw tangent. Now this tangent, it cuts the major axis in T. So this is T, and now Pn is perpendicular to x-axis. So this is your point N. So let this point P be a cos theta, b sin theta. Now this N will be a cos theta comma 0. Now equation of tangent at any point P, it is x cos theta upon A plus y sin theta upon B, and it is equal to 1. Now this point T, it lies on x-axis. So we'll put y as 0. We'll get x as a upon cos theta. So coordinate of this point T will be a upon cos theta comma 0. Now its center is C. Now what's Cn? Cn is simply a cos theta. And what is Ct? Ct is a upon cos theta. So we'll multiply them. Then Cn into Ct will simply be a square, and that's your option number 2. Now here the question is, if P and P dash denote length of perpendiculars from the focus and the center of an ellipse, when semi-major axis of length A on a tangent to the ellipse and R denote the focal distance of the point, then which of the following option is correct? So let the point be A cos theta and B sin theta. Now we know that focal distance is A 1 plus minus E cos theta. So that's your R. So R is either A 1 plus E cos theta or 1 minus E cos theta. Now we need to consider tangent to this ellipse. So any equation of tangent, we can write it as x cos theta upon A plus y sin theta upon B, and it is equal to 1. Now we'll find perpendicular distance from focus and perpendicular distance from center. Perpendicular distance from focus is P. So we can write P as AE cos theta upon A plus 0 minus 1 upon under root of cos square theta upon A square plus sin square theta upon B square. Now here A and A, it will cancel. So we can write this as AB, and then we'll have E cos theta minus 1 upon under root of B square cos square theta plus A square sin square theta and its modulus value. So that's your P. Now we'll find P dash, which is perpendicular distance from origin. So we'll get this perpendicular distance from origin as 0 plus 0 minus 1 upon under root of cos square theta upon A square plus sin square theta upon B square. So we can write P dash as AB upon under root of B square cos square theta plus A square sin square theta. Now if we'll multiply A with B, we can write AP as AB into A, and we can write this as 1 minus E cos theta upon under root of B square cos square theta plus A square sin square theta. Now this AB upon under root B square cos square theta plus A square sin square theta is nothing but P dash, and this A 1 minus E cos theta is nothing but R. So from here we can say AP must be equal to P dash R, and that's your option number C. Now question number 13 is, if the line 2px plus y under root of 1 minus p square equals to 1, where mod of p is less than 1, for different values of p, it touches which of the following conic? So we know that mod p is less than 1, then we can simply take this p as cos theta. Then we can write this as 2x cos theta plus y sin theta equals to 1. We can represent this as x cos theta upon 1 by 2 plus y sin theta upon 1, and it is equal to 1, which is nothing but it is equation of tangent to an ellipse, which is x cos theta upon A plus y sin theta upon B equals to 1. Now in this case, this value is greater than this value. So that means value of A here is 1 and value of B is 1 by 2. Now B square, it is A square into 1 minus E square. So E square in this case will be simply 3 by 4. Value of E will be under root 3 by 2. So this line for different values of P will always touch an ellipse whose eccentricity is root 3 upon 2. And that's your option number B. Now here the question is, a tangent to the ellipse 4x square plus 9y square equals 36 is cut by the tangent at the extremities of major axis at T and T dash. The circle on T dash as diameter passes through the point. So rather than solving this question specifically for this equation, we'll take any general equation. Say for example, equation is x square upon a square plus y square upon b square equals to 1. Now for this ellipse, equation of tangent is given by x cos theta upon a plus y sin theta upon b, and it is equal to 1. Now tangents at end points of major axis are represented by x equals plus minus a. So we'll put the value of x equals plus minus a. We'll get plus minus cos theta plus y sin theta upon b. It is equal to 1. So we'll write y sin theta upon b, and it will be equal to 1 minus plus cos theta. So we can write y as b 1 minus plus cos theta upon sin theta. So one of the coordinate will be a and then b 1 minus cos theta upon sin theta, and the other point will be minus a and then b 1 plus cos theta upon sin theta. Now we need to find equation of a circle with T dash as diameter. So we know that equation of such circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2. So this equation will be x plus a into x minus a plus y minus b 1 minus cos theta upon sin theta into y minus b 1 plus cos theta into sin theta, and it is equal to 0. So we can write this equation as x square minus a square, and here we can write this as y minus b upon sin theta whole square minus b square cos square theta upon sin square theta, and it is equal to 0. So we'll write this equation as x square plus y square minus 2by upon sin theta, and then we'll have minus a square, and here it will be b square minus b square cos square theta upon sin square theta. So 1 minus cos square theta and sin square theta will cancel, so it will be plus b square equal to 0. Now the result is this circle with T dash as diameter will always pass through foci of this ellipse. So we'll put x as plus minus ae, and if we'll put y as 0, then we'll get a square e square plus 0 minus a square plus b square. If from these two terms we'll take minus a square common, we can write minus a square 1 minus e square plus b square, and a square into 1 minus e square is nothing but b square. So it will be minus b square plus b square, and it will be 0. So that means these points plus minus a comma 0, they satisfy equation of this circle. So circle on any tangent having T dash as diameter will always pass through foci of this ellipse. Now we'll come to our question. In our question it says this circle will always pass through which of the following point. So that point has to be foci of this ellipse. So for this ellipse, value of a is 3 and value of b is 2. So we'll find its eccentricity. So it will be 4, 9, 1 minus e square. So value of e simply will be under root 5 by 3. So its foci will be at plus minus a comma 0. So it will be plus minus under root 5 comma 0. So this circle will pass through minus under root 5 comma 0 and plus under root 5 comma 0, and that's our options A and B. Now the next question is a vertical line passing through the point h comma 0 intersects the ellipse at points P and Q. Let the tangents to ellipse at P and Q meet at a point R, and if delta h is area of triangle PQR such that delta 1 is maximum of this value when h lies between 1 by 2 and 1, and delta 2 is minimum of this value, then we need to find the value of 8 upon root 5 delta 1 minus 8 delta 2. So we have this ellipse whose equation is x square upon 4 plus y square upon 3 and it is equal to 1. Now we draw a vertical line through point h comma 0. So this point is h comma 0. Now we need to find these point of intersections. So for both of them, x coordinate will be h. Now we'll put x coordinate as h, then we'll get y coordinate as plus minus under root of 3 1 minus h square by 4. So one of the point is under root 3 1 minus h square by 4 and the other point will be minus root 3 1 minus h square by 4. Now it says we have drawn tangents at these 2 points. These 2 tangents, they meet at this point R. So from symmetry we know that this point of intersection will lie on x-axis. We need to find x coordinate for this point of intersection since y coordinate is already 0. Now what we'll do is we'll write equation of tangent at this point. So we know that equation of tangent in this case is given by t equals 0. So it will be hx by 4 plus under root of 3 1 minus h square by 4 upon 3y and it is equal to 1. Now for point of intersection with the x-axis, we'll put y as 0. If we'll put y as 0, we'll get x as 4 upon h. So this point of intersection R, it is at 4 by h comma 0. Now we need to find area of this triangle PQR. So this is point P, this is Q and this is R. So area of triangle PQR, it is given by 1 by 2, then height in this case is 4 upon h minus h into this height, and this height is simply 2 under root 3 1 minus h square by 4. So we write this area as under root 3 and will be 4 minus h square to the power 3 by 2 upon 2h. Now we need to maximize or minimize this area. So we'll differentiate with respect to h. We'll get d delta upon dh and there will be root 3 by 2. There will be h and it should be 3 by 2. 4 minus h square to the power 1 by 2 minus 2h and then minus 4 minus h square to the power 3 by 2 into 1 upon h square. So from here we will take 4 minus h square to the power 1 by 2 common. So we will take it common, then we can write this as root 3 by 2 and we will also write this h square and 4 minus h square to the power 1 by 2. Here we will have minus 3h square and then minus 4 plus h square. So this d delta upon dh will simply be minus root 3 by 2 h square 4 minus h square to the power 1 by 2 and will be 2h square plus 4. Now h square is positive, square root is positive, 2h square plus 4 is positive and then we have a negative sign, so that means d delta upon dh is less than 0. So it simply means this delta as a function of h is a decreasing function. Now when the function decreases, its maximum value occurs at the start of interval and its minimum value occurs at the end of this interval. So we'll find its maximum value when we'll put h as 1 by 2. So we'll put h as 1 by 2, we'll get root 3, and this is 4 minus 1 by 4 to the power 3 by 2 upon 1. So it will be 16, 16 minus 1, 15. So we'll get this as root 3, 15 upon 4 to the power 3 by 2. So it will be root 3, 15 by 4, and then under root 15 by 4, and that should be root 3 root 5 upon 2. So we can simply write this as 45 root 5 by 8. So maximum value of this area is 45 root 5 by 8. Now we'll also find its minimum value, and we know that its minimum value will be when the value of h is 1. So we'll find delta 2. Delta 2 simply will be root 3, and if we'll put h as 1, there will be 3 to the power 3 by 2 upon 2. So it will be 9 by 2. Now we need to find 8 upon root 5 delta 1 minus 8 delta 2. Now what's 8 upon root 5 delta 1? 8 upon root 5 delta 1 is 45, and then minus 8 times delta 2. So there will be 9 upon 2 into 8. That should be 36. So 45 minus 36 is 9. So answer to this question is 9. Now here the question is, tangents are drawn from the point 3, 4 to the ellipse x square upon 9 plus y square upon 4 equals to 1, touching the ellipse at A and B. So first we need to find coordinates of A and B. So we have this ellipse whose equation is x square upon 9 plus y square upon 4 equals to 1, and this point is 3, 0, this is minus 3, 0, this is 0, 2, and this is 0, minus 2. Now it says from a point 3, 4. So from a point which is at a distance 3 and then at 4. So from this point, say P, which is 3, 4, two tangents are drawn to this ellipse. Now we clearly know that one of the tangents should be x equal to 3 line, and one of the point of contact will be 3, 0. We need to find this other point. Now for this question, since we have to find point of contact, we'll say let these point of contacts be x1 and y1. Then equation of tangent at this point x1, y1 will be given by x1 upon 9 plus y1 upon 4, and it is equal to 1. Now this tangent will pass through 3, 4. So we'll put x as 3 and we'll put y as 4. So we'll get x1 by 3 plus y1, and this value will be 1. So now we have two equations. Since this point x1, y1 will also lie on this ellipse, so it will satisfy its equation. So we'll get x1 square upon 9 plus y1 square upon 4, and this is equal to 1. Now we know that one of the value of y is 0, so we'll eliminate x. So we'll put the value of x1 by 3. So x1 by 3 is 1 minus y1, so it will be 1 minus y1 square plus y1 square upon 4, and this is equal to 1. So we'll get 1 plus y1 square minus 2y1 plus y1 square upon 4, and this value is equal to 1. So this 1 and 1 will cancel. So we'll get 5y1 square minus 8y1 equals to 0. That is, the value of y1 is either 0 or the value of y1 is 8 upon 5. So this point, it is 3, 0, and this other point will be B. Now we'll put y as 8 by 5, so it will be 1 minus 8 by 5. 1 minus 8 by 5 is minus 3 by 5. So x1 upon 3 is minus 3 by 5, so it will be minus 9 by 5. So this point B will be minus 9 by 5 and 8 by 5. So coordinates of A and B are 3, 0 and minus 9 by 5, 8 by 5, and that's your option number D. Now the second question is, we need to find orthocenter of this triangle PAB. Now we know that this line PA, it is perpendicular to x-axis. So altitude from B will be perpendicular to y-axis. So we know that equation of this line will be y equals 8/5. Now orthocenter will lie on this line. We'll drop a perpendicular from P also. Now this point of intersection, this is your orthocenter H. Now for this orthocenter H, let its x coordinate be H, and we know that its y coordinate will be 8/5. Now we need to find value of H. So we know that this PH, it is perpendicular to AB. So we'll write slope equation 4 minus 8/5 upon 3 minus H into, what is the slope of this line? Slope of this line will be minus 8/5, and here it will be 3 plus 9/5, and this value is equal to minus 1. So it will be 20 minus 8, 12/5, 12/5 minus 8/5. So it will be 96 upon 25. This minus and minus will cancel, and here we'll have 3 minus H, and it will be 15 plus 9. There will be 24 upon 5, and this value is equal to 1. So this is 5. 24 is 4 times. So condition we'll get is 3 minus H is 4/5. That is value of H is 15 minus 4. So there will be 11/5. So coordinate of orthocenter will be 11/5 and 8/5, and that's your option C. Now it says we need to find equation of locus of the point whose distance from the point P and the line AB are equal. Now this point P is 3, 4. Equation of ellipse is x square upon 9 plus y square upon 4 equals to 1. This AB is nothing but it is chord of contact of tangents drawn from this point P. So we know that equation of chord of contact is given by t equals 0. So which in this case will be 3x upon 9 plus 4y upon 4 equals to 1. So it will be x upon 3 plus y, and it is equal to 1. So this equation will be x plus 3y minus 3 equals to 0. Now we need to find locus of this point whose distance from this point P and line AB, they are equal. So we know that if the distance from a fixed line and fixed point, they're equal, in that case we'll get a parabola. So distance from this point P will simply be under root of x minus 3 square plus y minus 4 square, and then distance from this line, it is nothing but x plus 3y minus 3 upon under root 10. Now we'll square both sides. So we'll write 10, and it will be x square plus y square minus 6x minus 8y plus 25, and it will be x square plus 9y square plus 9 plus 6xy minus 6x minus 18y. So we'll get this equation as 9x square plus y square minus 6xy. Now it will be minus 60x and then plus 6x. So there will be minus 54x, then minus 80 and plus 18. So there will be minus 62. So minus 62y, and finally it will be 250 minus 9, and that should be 241 equals to 0. So equation will be 9x square plus y square minus 6xy minus 54x minus 62y plus 241, and that's your option A. Now here the question is, let f1 and f2 be the foci of this ellipse x square upon 9 plus y square upon 8 equals to 1. So we'll find its eccentricity. So we know that b square is a square into 1 minus e square. So we'll get the value of e as 1/3. So foci of this ellipse, they'll be plus minus ae comma 0. So we'll be at plus minus 1 comma 0. So we have this ellipse. with focus at 1, 0 and minus 1, 0. Now it says for f1 x is negative. So this is your f1 and the other one is your f2. Now it says suppose a parabola having vertex at origin and focus at f2 intersects this ellipse at point M in the first quadrant and N in the fourth quadrant. So we need to draw a parabola with vertex at center and whose A is 1. So we know that equation of this parabola will be y square equals 4x. Now this parabola, it intersects this ellipse at M in the first quadrant and N in the fourth quadrant. So first we need to find these points M and N. So we'll solve the two equations. We'll put the value of y square as 4x. Then we can write x square upon 9 plus 4x by 8 and it is equal to 1. So it will be 2. So we can write 2x square plus 9x equals 18. So we'll get this value of x as 2x square plus 9x minus 18 equals to 0. So we can write this as 2x, x plus 6 minus 3, x plus 6 equals to 0. That is the value of x is either 3 by 2 or the value of x is minus 6. Now x equal to minus 6, it is not possible. So the only value of x possible in this case is 3 by 2. So for this point M and N, value of x is simply 3 by 2. Now we'll put the value of x as 3 by 2. Then we can write y square equals 6. Value of y is plus or minus under root 6. So this point will be 3 by 2 comma root 6 and will be 3 by 2 comma minus root 6. Now this first question is, we need to find orthocenter of this triangle F1MN. So we need to draw this triangle F1MN. Now this altitude, it is x-axis itself. So that means orthocenter for this F1MN will also lie on x-axis. Now we'll draw another altitude. Say from this point M, orthocenter of this triangle will lie at intersection of these two altitudes. So let this point be h, 0. We know that product of slope of altitude and the opposite side is minus 1. So we'll find slope of OM. So slope of OM will be under root 6 upon 3 by 2 minus h, and then slope of F1N, which will be minus under root 6 and it will be 3 by 2 plus 1. So that should be 5 by 2 and this value is equal to minus 1. So we can simply write 12 upon 5 and it is equal to 3 by 2 minus h. So value of h simply will be 3 by 2 minus 12 by 5. So that should be 15. 15 minus 24 will be simply minus 9 by 10. So orthocenter for this triangle is at minus 9 by 10, 0, and that's your option number A. Now the second question is, if the tangent to the ellipse at M and N meets at R. So for this ellipse, if we draw tangents at M and N, these tangents, they meet at this point R. We know that if the point lies on the curve, then equation of tangent is given by t equals to 0. So we'll find equation of tangent at this point M, which is 3 by 2 root 6. So equation is given by x1. So it will be x and then 3 by 2 upon 9 plus y1. So it will be y under root 6 upon 8 and it is equal to 1. Now from symmetry we know that these two tangents, they'll intersect at x-axis. So that means simply y coordinate will be 0. So its x coordinate should be 6. So this point R is at 6, 0. And it says normal to this parabola at this point M, it meets the x-axis at point Q. So we'll draw a normal to this parabola at this point M, then it intersects x-axis at this point Q. Now for this point M, which is 3 by 2 comma under root 6, if we'll find the value of parameter t, then we know that parametric coordinate on a parabola is given by at square 2at. Now a in this case is 1, so it will be t square comma 2t. That is, the value of t is simply under root 6 by 2. We have already studied in parabola that equation of normal in case of parabola will be y plus tx and it will be equal to at cube plus 2at. Now this normal, it will intersect x-axis at this point Q. So for point of intersection, we'll put y as 0. So if we'll put y as 0, we'll get x as t square plus 2 and the value of t square is simply 6 by 4. So value of x is 6 by 4 plus 2, that is 3 by 2 plus 2. So it should be 7 by 2. So coordinate of this point Q, it is 7 by 2 comma 0. Now it says we need to find ratio of area of triangle MQR. So first we'll find area of triangle MQR. So this area will be half, and then what is the value of this base? So this is 6 comma 0 and it is 7 by 2 comma 0. So it will be 6 minus 7 by 2, and then what is the value of height? So height in this case is simply under root 6. So it should be 12 minus 7, 5. So it is 5 under root 6 by 4. So area of this triangle MQR is 5 root 6 by 4 square unit. Now we'll also need to find area of this quadrilateral MF1 and F2. So we have F2 here. So area of this quadrilateral MF1, F1N and then F2. So area of this quadrilateral will be 2 times area of this triangle. So area of quadrilateral MF1 and F2 will simply be 2 times and then area of this triangle, which is 1 by 2. Now what is height? Height in this case is again root 6. And how much is this distance? This distance is 2 units. So 2 and 2 will cancel. So it will be 2 root 6. Now we need to find ratio of these two areas. So ratio of area of triangle MQR to area of quadrilateral MF1 and F2, it will be 5 under root 6 by 4 upon 2 root 6. So this root 6 will cancel. We'll get this area as 5 by 8. So this ratio is simply 5:8, and that's your option number C. Now here the question is, let E1 and E2 be 2 ellipses. The area of the ellipse E2 is 1/3 the area of quadrilateral formed by the tangents at the ends of latest rectum of the ellipse E3, which is 5x square plus 9y square equals 45. The eccentricity of E1, E2 and E3, they are all equal. And it also says E1 is inscribed in E2 in such a way that both E1 and E2 touch each other at one end of their common major axis. If the length of major axis of E1 is equal to length of minor axis of E2, then area of ellipse E2 outside the ellipse E1 in square units is. So we'll start with this third ellipse, which is 5x square plus 9y square equals 45. So we can write this equation as x square upon 9 plus y square upon 5, and it is equal to 1. So this is our third ellipse, E3. Now for this ellipse, value of A is 3 and value of B is under root 5. We'll also find its eccentricity. So B square is A square 1 minus E square. So from here we'll get value of E as 2 by 3. So for all the 3 ellipses, value of E will be 2 by 3. Now it says at the end points of latest rectum, if we draw a quadrilateral, we need to find area of that quadrilateral. So what we'll do is we'll write coordinate of one of the end point of latest rectum. So coordinate of one point, say P, it is AE comma B square upon A. So which in this case will be 2 comma, and what's B square? B square is 5 and A is 3. Now at this point we'll find equation of tangent. So at this point equation of tangent is given by t equals 0. So we'll get this equation as 2x upon 9 plus 5 by 3 y upon 5, and it is equal to 1. So in intercept form we can write this equation as x upon 9 by 2 y upon 3, and it is 1. If we draw 4 such tangents, we'll form a quadrilateral, and from symmetry we can clearly say that area of this quadrilateral will be 4 times area of this one triangle. So area of quadrilateral is given by 4 times and then area of this triangle. Area of this triangle is half and then these intercepts, which are 9 by 2 and 3. So area of this quadrilateral is 27. Now in the question it says area of this ellipse E2 is 1/3 the area of quadrilateral formed by tangents at the end point of lattice rectum of ellipse E3. So area of E2, it will be simply 9 square unit. So let us say equation of E2 is x square upon a square plus y square upon b square equals to 1. So now we have our ellipse E2 whose equation is x square upon a square plus y square upon b square equals to 1. We'll draw this ellipse. This is a comma 0, 0 comma b, and center at origin. So that's our ellipse E2, and we know that area of any ellipse is pi AB. So we can write pi AB, and this value, it is equal to 9 square units. Now it says E1 is inscribed in E2 in such a way that both E1 and E2, they touch each other at one end of their common major axis. So we have another ellipse whose one end is same as that of E2, and length of major axis of E1 is equal to length of minor axis of E2. So that means for this E1, major axis is B and we need to find its minor axis. So we know that B square is A square into 1 minus E square. So it will be B square and then 1 minus E square. So B square, and since all the three ellipses have same eccentricity, we can write E as 2 by 3. So it will be 1 minus 4 by 9. So it has to be 5 by 9. So value of B is under root 5 by 3B. So what is the area of this ellipse E1? So area of ellipse E1, it will be pi and then AB. A is B and B is root 5 by 3B. So it should be pi root 5 by 3 into B square. Now we need to find area of ellipse E2 outside the ellipse E1 square unit. So we need to find this remaining area. So we need to subtract E1 from E2. But before that, we need to write this area of E1 in absolute terms. So we know that pi AB, it is equal to 9. We'll square it. We'll write pi square A square B square, and it will be 81. Now we can write this as pi square, and A square is B square upon 1 minus E square into B square into 81. So we'll write pi square B to the power 4 and it will be equal to 81, and 1 minus E square in this case again will be 5 by 9. So it will be this value 9. So pi B square, it's actually 3 root 5. So once we have the value of pi B square, we can write this area of E1 as root 5 by 3 into pi b square. Now the value of pi b square is 3 root 5. So this value is 3 root 5. So 3 and 3 will cancel. So area of this ellipse E1 is 5. So area of E2 is 9 and area of E1 is 5. So this remaining area will be 9 minus 5, and that is 4 square unit. So area of ellipse outside the ellipse E1 in square unit is 4. That's your answer.